Hey there, welcome back to the channel. This is an 88 Wrangler. Last time, put a link up here, we diagnosed that this thing had a crank, no start, and it was likely the ECU. So today, we're going to pull out the ECU, diagnose it, and fix it. The ECU on this is right there. So I'm hoping I can just take off this glove compartment. Looks like we've got some screws there and some screws there, and hopefully this will all come out and we can go straight in at the ECU here. Once you've got those bolts out, and in fact I'm unconvinced that those screws up there need to come out. The next thing is the fun one. We've got 4 studs, at least in this one it's studs, behind this. They go this direction, here, and here. They're up underneath the dash, so you've got to reach up under, and they're probably somewhere right about here, just for reference. So this oh shit handle, they're probably here and here on it. So you've got to get up in there with, I don't know, it feels like probably about a 10 millimeter, maybe a 12, something like that. And take the nuts off of those. Once you remove that, your ECU is really easy to get to. It's right here. Looks like it's got a single screw right here holding it in, maybe? There's the easy one here, but hiding back there is another one. And then one right there. This one shouldn't be too bad, but one way back there. That one looks like it's gonna suck to get. Well, after being under here cussing and swearing for at least the last 30 minutes, this is super not serviceable. I think the way it's designed is you're supposed to take the heater box out. At least I think the heater box went in after it. So, it sucks. Let's see. I did get the connector sort of disconnected. See that little metal tab right back there? You push on it and then you can lever the connector, but it's still hooked here. I still have that screw, if I can get light on it, right back there that I have to get. Of course, the challenge here is this, so you can see you can't get a ratchet on it and get this onto it. And then my deep well comes down so far that you can't get a ratchet onto it and get it up in there. So you need something mid-length between standard and deep. I don't know if you can tell how much shorter it is, but I just put it on the lathe. You could just use a grinding disc as well. Try to get it at least fairly flat. I'd say I took ½ inch off. But that was just enough to be able to get back in there and get onto that. Again, it's got this tab here that you end up, I've just pushed it with a screwdriver. You push it with one screwdriver and then come underneath this connector with another and lever it out. Once you've levered it out, as you're pulling this out, just do that. And the whole thing comes out fairly easily. You know, once you've taken the dash apart, of course, and modified a socket and said every swear word you could think of, then it comes out nice and easily. So here's the ECU. Early YJs use this Renix style. Later YJs, I do believe have, I don't remember who the hell makes it, but it goes up underneath the hood. So if it's underneath the dash, it's going to be one of these Renix styles. Like we've got torque screws in the corners that have to come out. All right, now let's open it up and discover, hopefully, something obvious. Wonder if this voids the warranty on the car. I'll call the AMC dealer and ask. Looking at it, I don't see a whole lot going on except right here. That looks like it got warm. Generally speaking, I just do an overview here. You can see how all of these traces, so the darker color is just the board underneath, and then the lighter one are actually traces. They are wires that are on this printed circuit board. And notice how they're all this nice bright green, right, everywhere. And that's a mask that's applied. And if you look around and then you get up into here and you go, wait a second, that's not bright green. It's also nice and shiny where all this conformal coating is, and up here it's dull. So that was the thing that I was looking for, and it became real obvious real quick that there's probably something going on here. I'm going to get a magnifying glass out and take a look at it closer, but we'll also use a meter and do some testing here to get a feel for how to test this and what exactly it is that is wrong. Oh yeah, right here by these diodes. That definitely got toasty. And it looks like that comes from the pin that is right below this. The way these are numbered in the bottom row, this is 1, 2, and 3. So this is pin 3, comes up, loops around here. Looks like it goes over to this diode. This one might have gotten hot. It's a little dull, but that trace definitely got warm. So I'm hoping that that trace itself burned out. All of these connectors look a little ugly to me. I'm going to take this board out and look at the underside of it too. And since I have the full wiring schematics for this vehicle, let's take a look and see if it makes sense that that trace being burnt is preventing it from running. So remember, that was pin 3 that the trace was melted on. This is the ECU. Pin 3 is the ignition. Now, I can't tell you why this got hot enough to cook, right? Basically, it's just power from when the key is on, comes down and comes in. So something caused that to burn up, but the fact that the ignition was burnt out and we weren't getting any ignition, it doesn't surprise me. This is the one that I was testing for the ignition output, and I wasn't getting anything here. But my suspicion is that this goes through logic, and then this is the output to this. So because this was burnt out, we're getting no output here. This is honestly one of the nice things about working on something of this age. All of this componentry, yeah, it's solid state, but they're very discrete components. And you can trace these things really easily with your eye. It's not like something new that would have, multi-layer boards with jelly bean components that for somebody like me would be near impossible to fix. Just based on the age of this thing, another thing that probably I should do is these can-looking things. There's one here, another one over here, another one here. Those are electrolytic capacitors. With age, they tend to go to crap. So it would not be a bad idea for me to replace all of those while I am in here as well. The whole thing is shiny, right? You can see it looks like it has something coating it. That's called conformal coating. That's to prevent moisture or anything else from getting to the board and corroding it. So we will conformal coat whatever we take off when we get to that point. But I am 99% certain that there is our problem right there. Well, let's take a look at where this trace runs. You can see it comes from pin 3 here, and it kind of goes under this pin, and then it comes down and it loops around and goes underneath these two diodes, and it connects to this diode. So really it's a wire that goes from here to pin 3. So first we're going to check continuity to see if we can go from here to here. Would not surprise me if it's broken because it looks like it's probably burnt right there. So I'm going to test with the meter, and it's off screen here, but you can see if I touch it, it beeps. Everything's conformal coated, so you might have to scratch through that. So those pins are not coated, but if I come here, I'm not getting any tone at all. Yeah, and if I just touch this, it looks super crispy. You can see this trace has even actually got so hot that it's lifted up off the circuit board. So that trace is actually broken underneath this diode. You can see it comes over, and it definitely got hot, baked everything, but look how the end of that trace right before it gets to the diode is just completely melted off. So it's supposed to connect to this one and run underneath here and connect to this diode. So we need to make a wire that connects from right in there. That's going to be the interesting part. We might be able to just hook the wire on right about there, but it has to come over and connect to this diode. This diode is a little bit dull. It may have gotten damaged. So what I want to do is I want to test it. In fact, I'm going to test these two. I'm going to test this one just because, see how it's a little bit dull gray here. That looks a little suspicious. Look at how nice and shiny all of this other solder is. But these all through here are all dull. So I at least want to test that this, and this are good, and then I'll test this resistor as well. Kind of wiggle around to get down through that coating. This is about a 1K resistor, and we can take a look at the bands to make sure it is a 1K. This meter right here has a diode check setting. I get nothing there, but if I swap them around, I get, half a volt. Check the diode drop here, about half. Should get nothing here. Again, let's check this large one. This conformal coating really makes it a pain in the ass to test things. There we go. So this diode is also good. We also need to take this board out, flip it over, and take a look at the underside. Let's take a look at this whole board. Again, looking for anything that looks suspicious, anything hot, anything broken. And this all looks very, very good to me. But since you can see we've got these standoffs that keep this side of the board off of this plate, gives us a gap under here. So what we can do is, for our repair, is we can run a wire on this side. That way I don't have to dig down and try to get between those pins. I can go right from here to the connection point that it needs to be. I think it's right here, but what we'll do is flip over and we'll just count pins and go out. All right, so we start the third pin in, and then this diode is 2, 3, 4, 5. It's between 5 and 6. So it's actually over here. 1, 2, 3. We're going to connect from here to between 1, 2, 3, 4, 5, and 6 to right here. Once we've done that, we need to glue this down so it isn't just flopping around, because I don't want it to come up and come in contact with this. But we're going to repair this wire by just putting a new wire, often called a bodge wire, on the underside. What I've done is I just took a wire, stripped the ends, and made little loops here and here, and I put them right on those posts. Now I'm going to give them some flux, give them some heat, and then put some solder on to solder that down. So I'm heating it enough that I see the existing solder melt. So I know I'm through that conformal coat, and then we'll give it a little bit more solder. Alright, so that is repaired. Now we just need to glue that down so it doesn't come up and touch anything it's not supposed to. I got in the resistors that I need. Basically, I just need one for this large one right here. I already had an assortment that'll cover the rest of these. Changing a resistor is pretty straightforward. We just have to be aware of a few things. Number one, again, make sure that the capacitance, so it'll have some number followed by like a UF. You can see this one says 1 UF, which is 1 microfarad. Right above that it says 50 volts. The capacitance, so the UF, the farads, need to match identically whatever it is that you go to put in and the old one. The voltage rating is the maximum voltage rating, so you need to be at that, or you can be above it. An example here is these are 100 microfarad at 100 volt, and this one is 100 microfarad, but only 40 volt. I actually couldn't find a 40 volt easily, so we'll go with the 100 volt. It'll be just fine. Now when we're going to put this in, you'll notice, in fact it's probably easier to see on these, see how they have that negative stripe on them? So these are polarized, so that needs to be toward the negative. Now you don't really need to know which direction negative is, but you need to make sure that the polarity is in the same direction when you put a new one in. So this one, the negative is facing this way, the new one has to be the same. So what I'm going to do is I'm just going to identify that, flip it over, make sure that you know which two pins, and it's in this case it's these two here, and you can see those are kind of folded over, which actually is going to make it a little bit more challenging. It's hard to pull it straight out when you have to straighten those pins. What I'm going to do is I'm going to heat this up and use some of this. This is just a solder wick. It's basically really fine copper. Put a little bit of flux on this and put it onto those points when it's hot, and it will suck a bunch of the solder up. So what I'm going to do is I'm going to try to suck up some of that solder and see if I can straighten those pins out. And once you do that, you just heat up one leg and kind of rock the capacitor back and forth. So you heat up one leg and rock away from it, and then swap to the other one, go back and forth until you can pull it all the way out. And you can see that it pulled some of the solder out of there. Now again, I'm going to just grab onto it with my hands, and I'm going to pull this direction to try to pull this one out a little bit while I heat it. So now you can see that it's got holes there that are filled with solder. A couple of things you can do. You can try to use solder wick again and try to clean those up. There are also things called solder suckers. One of these that basically push this down and then heat it up, and when I push this button it pulls out real quick and will suck out some solder. Might be a little hard to see, but I've got holes going all the way through now. Again, this one says it's 50 volts and 1 microfarad. So I'll find one of these. 1 microfarad, 50 volts. Always verify it on the can itself. Physically, it's actually a little bit smaller, it looks. Now on the board here, it's a little hard to see because of the coating, but it's actually marked right here. You'll see there's a little plus. So they're usually marked, but again, always pay attention when you take it apart. So we slide that down in, and we've got the leads. Just leave them sticking out, that's fine. We're going to cut them off after we've soldered it in place. I'm going to give it just a little bit of flux again. Now I just heat it and then add solder. Then I just cut these tails off. And there we go, capacitor replaced. Now I just have to go through the rest of the board and replace, I think, 4 other ones. 1, 2, 3, 4. Let's take a quick look at repairing this. So remember, that burnt out and lifted up off the board. I don't want this trace to bounce up and touch this diode, so I just put a drop of nail polish on there. You could use super glue as well, whatever is handy, but stick it back down to the board so that it isn't popping up. Next, we'll mask it. I'm going to use this. This is just a UV solder mask, so basically it's like green paint that will cure under UV light. So we'll put it on there, spread it around, get everything nice and coated, and then use a UV light to cure it. So I'll get a little down in there, maybe a little bit more than I needed, but I'm going to use a brush and cover all of the parts of the traces, even up into there. And now I'm just going to take a UV flashlight. Now that I have all the repairs done, I want to go back and recoat this, basically conformal coat all of the places that I heated it up to prevent it from corroding any of these terminals. Challenge there is I've got flux from when I did this, so I need to clean that up first. To do that, I'm just going to use some alcohol here and some Q-tips. Basically, I'm just going to clean up all of the spots where I soldered to try to get all of that flux off, and then we'll go through and coat this. Make sure you clean the top as well, wherever you did repairs or heated anything up. Last step is to coat. I actually have this, which is conformal coating, which is basically the same stuff that they had on here originally. You could probably just use RTV, but you want to make sure that you seal anywhere that you basically got through this coating before. So anywhere that you heated it up, down around the bases of these capacitors, and then on the back side. Putting it back in is pretty much the reverse. We're going to take the connector, hook it underneath here, and then lever it down until it snaps behind here. Not gonna lie, that was a pain in the ass, and the camera just was in the way, so sorry, didn't get any video. Now I just have it plugged in, haven't screwed it down. I'm going to at least try to start the car, see how we're doing. As you can tell, the belts obviously need to be replaced, but it's running. That's all I've got for you today. Thanks for watching.